Okay, how do we tackle right triangle trig? So this sine, cosine, and tangent deal with right triangle trig, but they only work in right triangles. So we're going to define today their ratios and how to solve them. So it starts with a right triangle. Here's how it works. Imagine this is a lake. I mean, really, let's say this is a triangular lake and this is you, okay? You're standing here and I say throw a rock to the opposite side of the lake. You would throw it here. That's my opposite side. We know in a right triangle that this is the hypotenuse, so we call this the adjacent side, which is next to us. So when we define sine, it's a ratio of the opposite side over the hypotenuse. When we define cosine, it's a ratio of the adjacent side over the hypotenuse. And we define tangent, it's defined as the ratio of the opposite side over the adjacent. Okay, now let's put some numbers here, okay? So we have example number 1, and we need to find the trig ratios from A and B. So we got two different angles. So if I first go to angle A, let's do angle A first, then I've got to make sure I label my sides first. Here's angle A. 4 is the opposite side because I throw a rock to the opposite side. So 3, that's the adjacent side because it's next to angle A, and of course the 5 is the hypotenuse. So if I do my opposite over hypotenuse, 4 over 5. Cosine, adjacent over hypotenuse, 3 over 5. Tangent, which is opposite of adjacent, is going to be 4 over 3. Okay? Now if I were to go to angle A, walk around to the other side of the lake and go to angle B, it changes some things because now I walked all the way over here. 3 is my opposite side of my lake, and my 4 is my adjacent side. So my ratios change. From angle B, my opposite over my hypotenuse is 3 over 5. For cosine, which is my adjacent over hypotenuse, is 4 over 5. And my tangent is going to be my opposite over my adjacent, which is 3 over 4. Okay? Now, where do we use this stuff? Because so far it's just a matter of just putting these ratios. So it's used quite a bit. So here is a real life example. Okay? So it says using tangent to solve these triangles. Okay, so first of all, tangent we know is opposite over adjacent. Let's see why. Here's my angle, and theta is a symbol for angle. Okay, and so when you see the symbol, it means angle. We know that this is our angle, so that's my opposite side, which is BC, and the 12 is my adjacent. So I set it up. Use my tangent of theta. Theta is 36 degrees, so I put 36 there. My opposite side, I don't know, I call it x. My adjacent side is 12. To solve for this, I'm going to multiply both sides by 12. I get an answer of 12 times tangent of 36. Well, anytime you do any kind of work with sine, cosine, and tangent, there's a mode. There are weird angle things called radians. We don't do that. If your calculus in radian mode, you're going to do all the problems right but get the wrong answer. Don't have it in radians. We're doing degrees because that's a 36-degree angle. So check your mode. Okay, so then I just used my calculator. Went 12 times the tangent of 36, and I get my answer, about 8.7. It's that easy. Okay. Second example, find the length of GP. Well, GP is here. So go to the angle. Here's my angle right here. That's my angle. Always go to the angle first. 15 is my opposite. X is my adjacent. Okay, this side is my adjacent side. That's my opposite side. So again, tangent. So I set up tangent of theta, but theta is 42. It goes to my opposite side, which is my 15 over my adjacent side, which is x. Now with x on the bottom, I got to multiply by x first to bring it up, and then I have to divide by tangent of 42. So I get, really, x is equal to 15 divided by tangent of 42. So if x is on the bottom, I just switch places, okay? So then again, I just used my calculator, and I went 15 divided by tangent of 42, and I get an answer of about 16.6, okay? Last problem, a real life story problem. Let's say you do have a 5-foot boy, and he sights the top of the tree at a 54-degree angle. And then he's 75 feet from the tree, okay? So I create a right triangle. I know the boy is 5 feet above the ground, so I will add his 5 feet in the end. So let's find the t. Again, there's my, from the angle, opposite side, my adjacent side. I'm going to use tangent. And I'm going to go tangent of theta, which is 54 degrees, is equal to the opposite, which is t over the adjacent 75. Okay, to solve for t multiplied by 75 multiplied by 75. So my t, my tree is 75 tangent 54. I use my calculator. I'm going to go my 75 tangent of 54. I get an answer of 103, but I have to remember to add in the boy's height, because his height is 5 feet above the tree. So add in the 5, and I get about 108.2. Okay, that's all I have. There's a worksheet out there on how to do this. If you have any questions, come see me.